Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 5, Section 7, the quadratic formula. Now, in class, we are going to derive the quadratic formula because you are getting to a point in your mathematics education where you should always ask where a formula came from. You should never just take it because your teacher said so. So we'll be looking at where this formula came from. But the purpose of this video is just to focus on how to use it in case you need to review this at home. So the steps for solving equations with the quadratic formula. Write the equation in standard form, set equal to 0, so that our coefficients are the correct positive or negative. The coefficient that is in front of the x squared is called the a, the leading coefficient. The coefficient that's sitting in front of the x is the b, and the constant, the number itself, is the c. So you grab these, just the numbers. You grab the a and the b and the c. You do not take any x's into the quadratic formula because the quadratic formula is solving for x. It's finding the x. And what's nice about the quadratic formula is that it always works. Sometimes factoring works and sometimes quadratics can't be factored. But the quadratic formula always works, whether the answer is two reals, two imaginaries, if it's 0, if they're complex numbers, the quadratic formula always works. So it's kind of like your ace in the hole. So we need to learn how to plug the numbers in and then solve for the x. Our first example is not written in standard form, so that's going to be the first thing we do. So I'm going to bring the 5x over as a negative and set this quadratic equal to 0. I want you to always very clearly show me what you have found to be the a, b, and c coefficients, because it's nice to check there if we made a mistake that early in the problem. All right, there is a 1 in front of that x squared. There's a negative 5 in front of the x, and the constant is a 4. So these are the numbers we're going to plug in to the formula. So the formula says we have minus b. So I notice right away that we have a negative b. So minus a negative 5 would be a positive 5. And then we have plus or minus, and then under the square root we have b squared. I'm in the habit of going ahead and squaring the b right away, so I'm just going to write 25. And you'll notice that even though the b was negative, we squared negative 5 and got positive 25. And then it says minus 4ac. So I'm going to put the a in parentheses and the c in parentheses. And we just want to do that to be very careful with our negative signs. All over 2a. 2 times 1 is 2. So now we need to simplify this. So let's focus under the radical here. Order of operations, we definitely need to multiply these three numbers first, and then we'll subtract from 25. So 4 times 1 times 4 is 16. And 25 minus 16 is 9. So this one kind of worked out nice because we have a perfect square. So let's go ahead and do the square root of 9, and we get 3. So now we have to split this up into the plus sign and the minus sign to get our two different answers. So the first x is 5 plus 3 over 2, which is 8 over 2, simplifies to 4. So that's our first answer. Our second answer is 5 minus 3 over 2, which simplifies to 2 over 2, or 1. So the quadratic formula gave us the two answers of 4 and 1. All right, second example. And once again, this is not in standard form, so let's take a minute and rearrange it by putting the 11 on this side as a negative. And now we can accurately pull out the coefficients. A is 4, b is 12, and c is negative 11. So plugging them into the quadratic formula, minus b becomes minus 12, plus or minus the square root. B squared, 12 squared is 144, minus 4 times a is 4 and c is negative 11. And this is all over 2a. 2 times 4 is 8. So now again we have to simplify it. Let's focus underneath the radical sign here. 4 times 4 times 11 is 176, but I just want you to be careful with your negative sign. The most common mistake I see is that students use this negative sign twice. They'll use it in their multiplying. For instance, negative 4 times positive 4 times negative 11 would be a positive 176, but then they subtract it, and that would be using the negative sign twice, so be careful. If you use it in the multiplying, it's used, and that's what I did. I used it in the multiplying. I got 176, and then we need to add that to 144. So then we're left with negative 12 plus minus the square root of 320 all over 8. Now I'm just going to give you a warning here. Don't start reducing this 12/8 yet. See how this is a term, and this is a term, and this is a term. This fraction has 3 terms. So if you're going to reduce it, it's all 3 terms or nothing. You reduce all 3 of them by the same factor, or you don't reduce at all. So be careful. All right, let's check this 320 and see if we can find a perfect square in there. So I found that 64 times 5 is 320, so we can take out that perfect square of 8. So now I have negative 12 plus minus 8 square root 5 all over 8. Now, since all of these terms, the 12, the 8 square root 5, and the 8, these all have a factor of 4 in them, we can reduce them all. So we'll take the 4 out of the 12, the 4 out of the 8, and the 4 out of the 8 in the denominator. And now this is our answer if we leave it in radical form. This is a perfectly acceptable form of the answer. Some textbooks, and yours might do this, if we're going to split this up, and the negative 3/2 does not reduce at all, so we're going to leave that as negative 3/2, but they may want to divide this 2 out of the denominator in the 2 square root 5. And that's okay if you leave the 3 divided by the 2, and your book may write the answer like this. But either one of these on the bottom here is perfectly fine. And again, later we will probably be asked to find these in a decimal value, and then we'll have to do the plus and the minus with the decimal value of the square root 5. All right, one more example. This quadratic is already in standard form, so I pulled out the coefficients, and let's put them in the quadratic formula now. Minus b becomes a positive 10 plus minus the square root. B squared is 100 minus 4 times 1 times 29 all over 2 times 1, which is 2. Let's simplify this. We need to focus on what's under the radical. We have 4 times 29, which is 116. So if we take 100 and we minus 116, what we're left with under the radical is a negative 16. And this is all over 2. But now we know how to find the square root of a negative 1, so this is no big deal. So this becomes 10 plus minus 4i all over 2. And once again, this fraction can be reduced if all the terms have the same factor. And here they all do have a factor of 2. So the answer can be written as 5 plus minus 2i. And that's the 2 answers. Now, pretty soon you're going to be asked, if you're given these 2 answers, go backwards and find the quadratic. So just keep that in mind, but that's for another section or 2. All right, now you have the knowledge you need to do section 5.7, so have fun with math.